Welcome everyone. It's really lovely to see you all here today to celebrate our dear colleague, friend and family member, Professor Abel Nyamapfene. Today we are celebrating the career and leadership and achievements of education-focused professors, one of whom is Abel. I've known him for a little more than 10 years now. I've had the great honor of working beside him on the project that is the IEP, and we share so much in common when it comes to our passion for engineering and engineering education. When we first met, we had very different remits. We came into the IEP as the original three that were brought in to completely change the way engineering was taught here. But his remit was to reform the mathematics curriculum. And my remit was to create a new core project-based learning. And what I remember when I first met him was his incredible smile and the warmth he has every time he meets someone new. And he just brings you in such a friendly manner. And I always knew I could come to him because he had the academic background I did not have. So coming to him for that confidence is what I've always done, but I also know that many members on the IEP team and the CEE, our Centre for Engineering Education, also come to him for that same type of confidence and leadership and mentorship. Now, his reach goes far beyond the IEP and the CEE, and I'd really like to read his bio if you will let me, because it really describes so much work that has gone into his coming to this point in his career as professor. So he's an experienced engineering education leader with core teaching experience in computer science and AI, electronics and power engineering, engineering mathematics, innovation, and entrepreneurship. He has extensive module and program leadership experience acquired from 6 universities across Africa and the UK, and has led the introduction of 2 very successful academic programs, that being the MSc at UCL of Engineering and Education, as well as the Catholic University of Zimbabwe flagship program, the Bachelor of Business Management and Information Technology Honours degree. He's a founding member of the UCL IEP, or the Integrated Engineering Programme, and our award-winning teaching framework that underpins the majority of the programs here in the undergraduate engineering offering. Prior to this, he led the modernization and the transformation of the MSc Electrical Power Systems Distant Learning Programme at the University of Bath, and reformed the common first year for the undergraduate engineering programs at the University of Exeter. He has published extensively on his work in engineering curriculum reform, and as we all know and we will see here today, he is quite the orator. He's a keynote, he has done many keynotes across the 5 continents. So he's very good at presenting, and that is one thing that will capture you here today. As a person, you will see in this presentation that he is constantly a learner, always trying to learn, always engaging others within the scope of learning. He's also a dreamer, which is really lovely to have on our team, because when we think about what we've done in the IEP and what is possible, it comes from the ideas and the dreams that we've always had, particularly within the IEP, or what I know of where we see the future of engineering education. So with that, I want to give the floor over to Abel for his presentation, and I'm really looking forward to this talk.
Thank you, Professor Emanuela Tilley, for this kind introduction. When you were talking, I could scarcely recognize myself. I thought you were talking of someone far away whom I have never met, but thanks for those kind words, and I'll cherish them. I don't know until when. That is interesting. I'm so grateful for all of you for coming today. I can see people who have made very significant contributions to my life. I can see my mom who had to come this February when it is so cold she's here. She normally wants to come in the summertime. Thank you for flying in. I can see my family, I can see my academic colleagues, those whom we started the IEP with, the challenges, the discussions we used to have with mathematics, the shouts we used to have, the agreements, the joy we had when things went well. I can see other colleagues as well. I can see my senior pastor here in Peckham. We used to call Peckham the capital city of London. He nurtured us, looked after us, and he said, I have to come here today, although he's feeling rather poorly. He is looking very well today. He had to come. Thank you for coming all the way from South London to Central London to Bloomsbury campus. I can see my in-laws all the way from southwest London. Who else? I can actually see colleagues whom I have worked with, colleagues from King's College London. I think there were some from Brunel University. Professor Chance flew all the way from Dublin, TU Dublin. She has been a close friend and a supporter for the IEP. We've worked very closely. She has mentored me. She has introduced and connected me to a lot of people. I can see, of course, Kate, we've been in the trenches together for 8 years. We are still in the same trenches. And most importantly, I can see one, I think Dr. Chika there and Dr. Reza there were PGTAs, what we call PhD students, went through our hands. Now they are lecturers, associate professors through the program. I can see my colleagues, first from the University of Bristol. I think I lured it into to UCL. So it's a big, big family today, and I'm so grateful for all of you, those whom I have mentioned, those whom I haven't mentioned. Let me try to see whether the slides are working. I'll start off with these two colleagues here. In inaugural speech, normally there's no introduction. That is what I've learned from observing so many of them. Tommy, I didn't say hi to you. That's one of our first MSc students on the Engineering and Education Program. He's now doing a PhD here. Thanks for coming. Two colleagues, I think we've made a significant change in my life. The first one is Professor John Mitchell. When I met him, he was not a professor yet. He was still Dr. John Mitchell. I had come for an interview. I was coming from the University of Bath. They'd advertised this thing, and I've been reading about engineering education, and I thought, let me go and see what they have to say. Then he sort of convinced me, and then I thought, okay, I'll go back to London. I came, then I realized the University College London is way, way bigger than all the universities I had been to. I was to take charge of a mathematics program with almost 800 students. My whole faculty of engineering at my other university, you counted the students, there were 400. I was to work with colleagues, professors. Those days we used to say big, big, big professors because I was still a small or junior academic. We had to work with 28, 30 academics, seasoned academics, and I was to tell them, you do this, you do that, you do that. I thought, I think I don't want this job. Then he wrote again, I sent you an email last week with this offer. Are you going to take it or not? Then I consulted, as usual, my wife, and then he said, okay, I'll take it. Then he sat me down and started teaching me how to go about management. So John has been a big influence in my life. He continues to be a big influence in my life. And of course, Professor Emanuela Tilley, with the three to come in, we accepted a challenge. I'm not sure she really understood what she was taking on, But his was the biggest, the 10 key module, the challenges module. And we worked together 2 years, 3 years. It's still the centerpiece for the IEP. She has progressed. She is now the director for the IEP. We are very close. She mentors me, I mentor her. We are a small set of friends, as it were. I think it's now working. Yes. Then I came to London in 2002. I wanted to do a PhD. My brother was staying in South London, so I went to South London, Peckham. Sunday, he had gotten into the habit of going to church. I think I had last been to church 20 years ago. So, okay, I politely went. But I later realized that that was quite important for me because the whole setting in London provided a community where I could settle in, where if things were not going well with my PhD studies, there was something, a shoulder to cry on, someone to talk to, someone to say, these things are not going well. I'm thinking I'm going back home. I have had enough. They think I don't have a country. I'm going away. So he was the calming influence, calming voice in my life. He looked after me, mentored me, nurtured me. Not only me, but quite a number of people who were at my stage also doing postgraduate degrees. Some who have gone on to do other things in the United Nations and so on. So that's retired Major Reverend Dr. Samuel Labi. And I think some of the things he had gotten to learn them because he had come here as a student and went to the Royal Military Academy, Sandhurst. So he had trained there, experienced what it is to be an international student. And when I look at the research on doctoral students, why most students fail to complete their dissertations, their PhDs, is not that they find it hard to do. No, it's the things happening outside of their lives that we call that belonging. Do you feel like you belong to the university? Do you feel like you belong to the academic community that you are part and parcel of? In some way, Pastor Sam sensed that and provided that environment for us. So perhaps the PhD that I now have and perhaps this celebration, if there hadn't been a community, the one that he nurtured and built, perhaps we might be talking of other possibilities, but perhaps not this professorship. So thank you, Dr. Samuel Labi, for the help and the effort that you did in our lives. And of course, there are many days that change in life. This one was, I think it was June 29 or the day before. I was sitting on my computer, working away, and then my head of department calls, and he calls right on my mobile. And I'm thinking, mobile phone, this is a London number. This should be an Institute of Education number. Then I answer, hello, he's not here. That's Professor Brad Blitz, the head of department in the Institute of Education. And he said, I've got something I wish to discuss with you. Do you have a moment? Is it the right time to speak? And in that moment, time freezes. You start thinking, was there a student I harassed or didn't treat properly? Are things going well? You start thinking of your conversations with colleagues in a flash, and of course you say, yes, Professor, it's okay, it's okay. Then he says, congratulations, and he tells me, at least he used the UCL promotions committee had said, I think you are good enough to be a professor for teaching. That's how it came through. Of course, I had applied, put together an application, but with all these things, you never know. It's always, if you're on the other side, it's a hit and a miss. So my life changed. Then I started thinking, oh, okay, I'm a professor. How am I supposed to do? I think I need to change the way I walk, the way I talk. It has been a challenging 8 months, I think, since then. I've been grounded, learned through it. Professor Tatiana did sit down with me and say, Abel, you know, things have changed. You are now a senior academic. And I'm imagining, oh, I'm now a senior academic. What am I supposed to do? But I thank God for UCL. This has come to pass. I'm so grateful for it. But then there's always that lingering question. Why did they make me professor? I know my senior colleagues, they have very strong reasons for why I should be. Then perhaps some misgivings for saying, I think but I think you did enough. So I thought I need an institutional voice to really confirm that I am a professor. So I applied for what we call the Principal Fellowship for Higher Education Academy. But I'll go on a bit. I hope I get this to read.
I've been given the lovely task to try to figure out what people think their definition of a professor is. So with the help of Professor Abel to describe what a professor is after, here are a few clips of people giving their definitive answers of what they think a professor is.
A professor is someone who has reached the pinnacle of their field and has the highest scholarship and has contributed to the advancement of their field, but also the development of others through medical education endeavours. I've always appreciated the professors that have helped develop me to where I am, and I can't wait for Tilley to start his work as an official professor.
Personally, I think a professor is someone who obviously lectures in uni, focuses more on research, and they're really, really passionate about their job.
So I don't really know what a professor is, but I think maybe something between a researcher or an educator, and everything in between, and a mix of both those things is what a professor is.
A professor is the boss of the work.
I think a professor is someone who has done masters, who has done PhD, and a professor, you have studied everything.
People that help people in uni and does research.
A professor is an academic wizard.
So, Professor Abel, with all of these answers, can you please tell us what is a professor?
We've always argued with my girls, as you can see. The only boy there, that's my son-in-law. What is a professor? What do you really do? And we always have these arguments because they look at me sitting on my computer, especially when I'm working at home. I start at 8 o'clock. I'm there at 10 p.m. I have meetings throughout the day, some to do writing of papers, discussing what is happening in the university and other things. And they say, what do you do? And I say, I teach. And they say, but we hardly see you teach. Then I say, I research. But then they come and say, but what is research? We don't see the machines, the artificial intelligence, and all that. So I didn't have answers. But certainly, I'm no academic wizard. I'm just an ordinary person, I would like to believe. Do I really understand? Am I at the top of the academic ladder? No, I see many, many more eminent people here who really deserve to be like that, but I'm still far away from there. So when I applied for the Principal Fellowship, this is Dr. Jenny Griffiths. She heads the fellowship panel in UCL Arena at the other end. So she wrote all these things, and I was looking at them, leadership and mentoring roles. And I thought, I don't really know, but some might quibble with that, but she wrote it, pivotal transformation of first and second year modules. And I said, but I was working alongside many other colleagues, most of you who are here. Widening knowledge through publication, yes, I have written, but mostly I have written with colleagues here at UCL and elsewhere. When you write, you partner with someone. I like that academic argumentation where you argue with someone, you agree, you look at a point, and then you come to a conclusion, and that's part of our life. Design and leadership of a cross-faculty. Again, I worked with Professor David Gale and John Mitchell to come up with this. I was more like the boy who runs in front and do things while they tell me what to do. But they wrote it, commitment to implement and improve education-focused career track. I just happened to be at the right place at the right time. Hi, Mike. Thanks for coming. That's one of our colleagues whom we work with. He's in biochemical engineering. And I think we've had many of these arguments together. When I joined in, there were no education-focused or teaching-focused academics. So I think I was amongst the first group of people to be given this title. So to differentiate us from what was said with the proper academics, they called us teaching fellows. So we'd go, I'm a teaching fellow, then you go, I'm a senior teaching fellow. I did make it to the higher level, the principal teaching fellow. Then they decided, I think you look like academics, you must be academics. So we became assistant professors, associate professors, and now professor of teaching. And I did work alongside Professor Tilley to look at the promotion criteria for teaching-focused academics here at UCL. And as they always say, UCL is such a big university, quite well known within the UK and internationally. If something does happen at UCL, the waves reach out everywhere. And you actually find that because UCL accepted that someone could focus solely on education and make it to a professorship, it is now much easier even in the other smaller universities for people to get that accolade. The work that we did here, which was the Integrated Engineering Programme, if I had done it in my earlier universities, people would have said, that university, they did it. Okay, they are only small, it's only a regional university. But when things happen at UCL, people look up. And that is the opportunities, I think we have managed to leverage the engagement that we have, not only in the UK, but in Africa, across in Asia, the links ups we have with people in India, South America, even in the US, is probably to a great extent due to the reach and the extent of this university. So again, I'm thankful for having gotten the opportunity, for John to have said, okay, we can take you, and given me the opportunity to be part of this university. So I've been trying to think, of course, I know I'm a big, but I'm not as big as this. But I was thinking why I do what I do. And I thought, what do I really do? I used to be an engineer, believe it or not, a long time ago. So I used to enjoy calling myself Engineer Abel Nyamapfene, and that was quite nice. Why do I teach? Was it by accident or not by accident? I grew up, of course, in a family of teachers. My mom, my dad, my uncles, they were all teachers. We always sat around the table. Probably I really didn't need to go to college to teach because we were always teaching, we were always discussing students. I was always going to my dad's class in primary school in St. Aidan's, walking around, looking around, even assisting with the teaching, do this, do that, do this, do that. So I think perhaps I grew up within teaching. And even when I was in engineering, I always said, at least one day I might want to be associated perhaps with an education faculty. And of course, Professor David Gale, it is facilitated that for me, and I got an opportunity to be part of the Institute of Education. So education, engineering, I think I'm quite at home with both. Of course, I'm not the par excellent researcher in education, but I'm good enough, I think. Why engineering? I chose this this gentleman here, originally from Ireland. He worked up his way up, writing poetry, plays, and then he realized that if you want to make money, you need to go to London, so he came to London. He became quite famous. Some say when it comes to literature, he's second only to Shakespeare. So he never did engineering, but I liked what he said. He says, you see things and you say, why? You are always in a state of wondering. But me, that is, he was telling himself, I dream of things that never were, and I say, why not? Emanuela, I think perhaps I took him too literally. But I think I like dreaming, because in dreams there's hope. In dreams you can reconstitute, you can change the future. And I think that is why we are in education. And when I do get a new batch of students coming in, I look at them, I talk to them. They want to do great things. They want to be this big engineer, this big entrepreneur. And my job is to provide them with the skills, the hope. Sometimes it's only to make that passion burn much, much more strongly, that they go through the education system. They go into life and start building new things. And as I was saying, when engineers come, the first thing they do, students, is not to do the mathematics. It's not to do the deep, deep equations. It's to solve things they are thinking about in life. It might be cars, electric cars. I think my brother Ivan remembers our faculty of engineering at the University of Zimbabwe. They used it to entice people with a electric car model. So open days, they'll be driving that car around. What happened was the faculty of engineering was next to the medical school. My mom and dad thought he's doing A-levels, he's going to do medicine. But then the car park was on the other side. You go to the car park, pass through engineering, and there's this car going around. And that was 1986 electric car, not the cars which were used for transporting milk or anything. A special car that looks more like a Tesla today. I was taken and I thought, so if I do engineering, I might actually be designing these things. Then, of course, I proceeded to the medical school. I saw the skeletons. I was no longer listening, went back, signed up for engineering. I think I didn't contact anyone back home for a month or so. And then they said, so you are going to do medicine. And I said, no, I like mathematics. I'm not going there. Anyway, that's how I became an engineer. Then the most important thing when you become an engineer, is that creative work you do. It's not exactly completely overly technical, but you build things. You see how grateful people are when you create something. My sister was already teaching next to this place where you see these pictures coming from. It's in the eastern part of Zimbabwe. We call it Nyanga, Bonda area. And we are there doing those installations, setting up the first telephone system. It was the days before the mobile phone. So when you could actually see the health center, the clinic, they are now able to telephone the district hospital. Someone in the village, they can actually pick up the phone and call someone in the capital city. That was revolutionary. Not a big thing international, but it was revolutionary. So when I teach, I always say, if a student could have these moments, these creative moments. And then the question came, why can't it start earlier when they join engineering school? And that has driven me, I think, for quite a long time, all my life really up to today. And it's what I think drives the IEP, or what we call the Integrated Engineering Programme. Before I go on, I think I'll tell you a little bit about my personal philosophy. Most of you, I think, might be familiar with Jean Piaget. He's famous for his work on child development, cognitive development. I think I do know we have a psychologist in the house, and I can see a nod in her head. I shall not speak. But he also dabbled in education. He was director of the Education Bureau in Switzerland, in addition to doubling up with his research. And where we agreed, he said the principal goal of education is to create men. Of course, in 1964, probably, these guys thought, women can't do education, it's only for men. So I've deleted that, updated, it's now individuals. So the principal goal of education is to create individuals who are capable of doing new things, not simply repeating what other generations have done. Individuals who are creative, inventive, and discoverers. And what you find is that was 1964. This time we are talking of what we call generative artificial intelligence, or ChatGPT. Most of us have heard of it and interacted with it. All it does, it goes through work that has been done in the past and reconstructs it and feeds it back. So is there something new? Possibly, but very little. But can we really teach individuals to be creative, to generate new ideas, new ways of becoming, new ways of looking at the world, new ways of reconfiguring the world so that it becomes a good place, a better place for us all? That's perhaps what partly drives me to stay on in education. And most importantly, coming on, I think these are part and parcel of the tenets coming in from the Institute of Education. Are the people you are educating, are they learning to be critical? Are you not just teaching them to repeat what they have been told? Oh, someone decided to call me. Whom do I give? I think I'll give them my phone. So if you are able to get information, think critically about it, and you are perhaps inventive, can critically appraise an invention, I think it is a good place to be. And of course, we also learned from my colleague from South Africa. Of course, he ended up being called in a South African-born American, Simo Papet. He's one of the normally written down as leading founders of artificial intelligence. And he also did quite a lot in education, AI, computer science. And he says the role of the teacher is to create conditions for invention rather than to provide ready-made knowledge. And this is what, again, we are setting out to do here at UCL. It's not easy to do that. But again, with artificial intelligence as it is, ChatGPT, we now realize that the journey that we started in 2013, 10 years ago, we are only just starting. How do you come up with a curriculum framework? How do you come up with teaching approaches, pedagogic approaches that ensure that the next generation of students are able to learn, are able to become independent individuals, are able to master and control the ever-increasing intelligent machines that are coming on. So that's my personal philosophy. I think I've already talked about why did I become a proponent of integrated engineering education. What you can see here, these are our students. they are not master's students. They are typically first-year engineering students. If I went to some other university and they looked at this circuit, they say, I think that should be third year. No, this is first year at UCL. Then just to move forward, when I did my degree, it was maths heavy. We went through, I think we basically did a full degree in mathematics and then added a little bit of engineering, and that was it. And when I finished, of course, I was now an expert at mathematics, we celebrated, but the key thing was I didn't have that practical expertise in engineering. I could analyze things, but perhaps I didn't really know how to do that in practice. I take my first job, and what do you find? There's no mathematics there. These were the days of the electromechanical telecommunication systems. I worked in the exchange. And you are looking at guys moving around, and you are just told, you are there, you are the new, they call that graduate engineer, graduate telecom engineer. You are supposed to be knowledgeable. And the young boys and girls, they are running around fixing everything. And you are standing there trying to read relay A, RLA, RLPT. It works this way, you are confused. We went through confusion for 3 months, 4 months. I had to unlearn what I had learned and relearn new stuff. And he said, this should not be, I think the engineering degree has to change somehow. Basically what I learned, again, these are some of our students. Effective engineering practice requires teamwork in between engineers, technicians, and other professionals. We didn't know that as students, but in practice, that's what happens. And can we integrate theory and practice? Here comes the Integrated Engineering Programme. This looks dense, it's heavy, but we said, let us summarize everything we know, say, about the IEP. We want to tell people that this is what we do. Our focus is on interdisciplinarity, sharing of experiences. Yes, you are an electronics engineer, but can you work with someone from the School of Education? Can you work with someone from the School of Management? Can you work in projects? One thing you realize, it's quite difficult for people to work together as a team. That's a key challenge in the workplace. How do we teach students to work in teams and to be productive, to take advantage of the skills of others, and to cover up and train others who are not so skilled in other areas? Team-based learning. And of course, for me, mathematical modeling and analysis. Can you use the maths that you are learning to come up with useful models that contribute and advance engineering? And what we call authentic learning, are we able to teach students in a realistic way? Perhaps projects that they can relate to, something that they can go home and sit down with mom and dad and say, I did this at university. This is what the IEP is all about. That one is a little bit more detailed description of what I have said. But I think, correct me guys if I'm wrong, but this was our moment of realization. We're trying to get feedback from staff, from students about the Integrated Engineering Programme. So the basic question was, I think someone had read some paper somewhere and said, if you actually ask students or people to draw, ask a question and then say, draw an answer. This is what happened. And one student, I think we should have gotten her name, she came up with this. This is how she pictured the Integrated Engineering Programme. Year 1, Year 2, Year 3, Bachelor of Engineering, graduated. That's the picture that came up. And what do you see? It starts with projects. Students are working on projects. They work on short-term projects. They work on a big project at the end of the second year. In third year, they work on a big individual projects. My mathematics and other disciplines, thermodynamics, all the interesting stuff we academics pride ourselves in teaching, it was pushed to the other side. Professional skills, design and professional skills, which I think Dr. Chika now leads, it was all pushed to the other side. So we understood that our students, when they are on the IEP, they are beginning to take the subjects, the modules that we teach, and say, these are only there to make us better at doing project work, engineering project work. And from there on, we realized we have provided a change in mindset in how engineering education is done. Before it would be, I do maths 1, maths 2, I do calculus 1, calculus 2, I do physics. No, we do projects and we reinforce that with knowledge. Then along the way, my colleague, I think Dr. Fiona Truscott came up with this to capture a student's journey. I'll put in everything. That's the very first project. Students are thrown in together, they are work in teams, they've never met each other, but they have to meet an objective, week 1. We have first term, second term of the first year, engineering challenges, really serious projects, where other people will be saying they are not educated enough, they don't know enough engineering. Our students are producing good stuff there. Scenarios will come to that. You see they are becoming, even within 1 year, 2 years, effective engineers. How to change the world. We used to say engineers are not good entrepreneurs. Engineers like working with things. They don't think about making money or making a better world. Come to our How to Change the World in June. You will see novel things. When we started How to Change the World, we didn't have Boris's bike scheme. I think you still remember, it was 2015 or thereabouts. Students were even coming up with the concepts. We might have a way of having bicycles in town, motor and electric vehicles in town, and that would reduce pollution within London. They came up with ways to reduce pollution, even in the River Thames. And you think, if we could develop these projects, put more money behind them, these students could be in a very different place. Of course, that's our challenge too. For those who might not know, Uganda is a relatively small country in the middle of Africa, right on the equator. And that's where Emanuela led this, but it was part of the challenges. The idea was take a country somewhere where students might not even think about. Do something novel there. Let us think of how to develop a vaccine. What does it take? You need power, you need chemical engineering knowledge, you need knowledge of chemistry, you need knowledge of biochemistry. I don't know, probably pharmaceuticals, everything. Divide up the students and let them do it and manufacture it. This was the idea. So the first day they'll be asking, where is Uganda? I've never heard of Uganda. Are there trees in Uganda? Is there what? They look at videos, they watch the videos. And I can think, because of this program, it has been running for about 10 years. Perhaps we have boosted tourism in Uganda. People have gone to look at, oh, there's Lake Victoria. Yeah, I'm going there to see. Teaching in context. And this is the reality. They make up models. They are working in groups. My daughters, I think, used to say engineering is not for girls. But look at the number of lady engineers at UCL, all producing and working effectively. Scenarios, these are short-term projects. You study for 4 weeks. We stop teaching. You have to produce something. And you are working in groups. We solve problems to do with ice cream manufacturing, that is chemical engineering, issues to do with renewable energy. Throw them at the students in their first year, and you see them researching in the library, talking to people in industry, getting ideas and facts, and coming up with solutions. I think that was one of our first successes again on the IEP. What I really like about this, it's 6 months into their degree program. In August, September, they were in high school doing A-levels, thinking about maths, physics, chemistry. 6 months later, they have designed a contraption that goes up a smooth pipe, pauses momentarily to say hello, and then goes down comfortably. 6 months of UCL Integrated Engineering Education. I think I'm overselling the IEP, isn't it? But this is the reality. This is what is happening. And this is what can be achieved. And most importantly of all, you realize we began to think, we used to demand mathematics, physics. And John was saying, do something to support entry of students into mathematics. We set up a mathematics support program. And we went on, John and other colleagues, we now have what we call the Engineering Foundation Program. It brings people who aspire to do engineering, say in the top-ranked universities. They come in, they spend a year, they get to have a feel for what it is to be in university. We interact with them, we do projects with them, we go, it is taking place in East London. We have colleagues who are teaching on the program. We go there and support them. Next year, the students are moving into engineering. And I think of my colleagues, the kids, our kids, say in South London, and say, this is a perfect opportunity to get into engineering. This is a perfect opportunity to do engineering at UCL. Why I teach mathematics in the context of engineering problem solving? Most youngsters might not know this old man there. I don't ask. This is the famous Einstein. And of course, he did quite a lot in mathematics and in physics. I think you know a little bit about light, speed of light. I think he has the ideas, but that's him. When I joined the Telecommunications Corporation in Zimbabwe, I knew nothing about engineering. I had done a strong mathematical degree. I could design telecommunications models. I understood them. What I learned during my preparatory phase was to understand physically how to deal with telecommunications equipment, microwave links, installation of microwave links, troubleshooting them. And I ended up in what we call the maintenance support unit, the development laboratory, where my job really was to wait for those problems that are not solved easily by maintenance and operators on the ground. They would then say there's this issue, a recurrent issue. And then, of course, they would come in, drive in, and they say, oh, the guys from the development laboratory would come in. For some reason, they asked us to wear these white dust coats, so we'd be coming into the exchange with white dust coats. I could have gone in my nice clothes, but it set a measure of difference. The Mazoe Earth Station back then in 1992-93, it was the only telecommunication link for Zimbabwe to the rest of the world. And for some reason, there's what we call interference. You are talking on the phone, suddenly you hear nothing, woo, everything disappears, and you say, I was talking, it's dead, it's dead, it's dead. Where still you'll be sending data, perhaps monetary data, finance, everything just disappears. A solution was needed. It was an urgent problem. The head of the corporation was on it. People in government, also they told us, managers sometimes lie, don't they? They're saying, the president's office is saying this, the president's office, they are worried, this is sabotage, this has to be solved. And so I went with colleagues to resolve the problem. We looked at the data that had been collected, testing, signals, frequency data, came up with models. This is what we call a mathematical model of if you are solving a thing using mathematics, how do you model it? We implemented something of this nature. We hadn't yet started mathematical modeling, but we analyzed the system. We guessed if this is interference, the frequencies, affecting frequencies must be coming from this end. This is the affected module. We tested it out. It worked okay. And then we said, now we must put it into practice. And the solution was very simple, like I think you find with radio equipment. The analysis is fiendishly difficult. The solution very easy. All you needed to do was to make a metal encasing, a small metal box, cover the problem equipment, and everything became okay. And then I was thinking, this is mathematics in practice. If we can teach mathematics in practice to students, what will happen? I couldn't confidently do it where I was in the other smaller universities. But John gave me an opportunity to try out, and with colleagues we went and tried. I'll come to that shortly. Talked about the lessons, just a summary. Again, these are some of our biochemical engineering students working on something. Students may lack the motivation necessary to obtain a thorough understanding of key mathematical concepts. But if you know the mathematics and you go into the field, if you marry the two, you become a very effective engineer. So my first attempt at solving this was to come up with a module, a master's level module. We called it the digital signal processing module at the University of Exeter. But there were two important things. Rather than just teach the theory, the mathematical theory, we introduced MATLAB. And of course, when I came here, I carried on teaching through MATLAB. You analyze things there. I won't go into that detail. And most importantly, you could actually build a circuit that implements that. And you will be using what we call, of course, we call it a field programmable gate array. All you did was you then wrote some other program which reconfigured some hardware circuits, and you connect your input here, you get your output at the other end, and it is operating perfectly. You can take this board, plug it into a whole working system, and it will work fine. And of course, our students, after this course, they will be doing more advanced research topics, more advanced modeling topics. This is what I brought basically to the UCL when I was given responsibility to oversee mathematics. What was I supposed to do with the mathematics? It has to be problem-based led. It has to be, students have to interact with current mathematical tools. It is not just mathematics, but take the mathematics, add tools to it, analyze it using software. And we are doing a lot of research projects. I think we are one of the top universities as far as research is concerned. Why not bring that research into our mathematics teaching? Those were some of the requirements that I was given. Of course, this was a 7-point plan which became the learning outcomes. I think we have basically achieved most of this stuff, but work is ongoing. The world is moving on. Typical coursework, you don't just go and do it. I can see people getting frightened. I won't ask you to do that. But you still see, when I say MATLAB or Excel, you are using computer software to analyze these things. You understand mathematical concepts, you build models, you test out something using these computer software there, MATLAB and Excel. Typical exam, I think this is the typical mathematics exam. There's nothing to do with programming, there's nothing to do with real life. It's what I would call hardcore mathematics. Now, what was the change that we introduced? When we started talking about having a project in mathematics, it seemed to be a no-go area. people had talked about it, but we were going to implement it for 800 to 900 students. A project for the first time. If it went well, that would be fine. If even the very least thing happened, is they do happen sometimes, your jobs could be on the line. People will start wondering what's happening here. That's the sort of risk we took as a team. And what we did, this is based on the PhD work of one of our current lecturer in the second year mathematical modeling and analysis. She's not here today because she's traveling. So she looked at her PhD work and said, I can simplify this and give it to our second year students, and they can model it, they can analyze it and come up with solutions, and they have to do it within 48 hours. She prepared some data, gave them instructions, described as best as she could how blood flows in those small veins in the body. That is what they were to analyze. They are only in their second year, mind you, but they were analyzing that and coming up with solutions. And we said the key thing that we did was we realized that these are students, they need additional support. And the university, the Faculty of Engineering Sciences, they were happily provided us, at least with enough resources so that we can support the students in their work. So one thing which often misses out in curriculum change is, is the university willing enough to provide sufficient resources? I think over the past 10 years, we have been well supplied with resources, and I think the outcomes have been quite commendable, I must say. This is just a sample continued. This work, it described what my master's students were doing. In the first, when I said they bend it onto an electronic system, our students are doing it in the second year. Carrying out that analysis at second year, which other universities are doing at master's level. This is how, at least, mathematics here at UCL is sort of revolutionized how we teach mathematics in engineering here at UCL, here in the UK, and internationally. I think I've already talked about that. My next 10, why entrepreneurship education is central to my teaching. I must say I started getting into entrepreneurship almost by accident. Then it was 2002. I know my brother at the end remembers that period very well. That was 2002. I was in Zimbabwe, teaching at the University of Zimbabwe. Then things started going wrong. If you must remember, I think that picture, do I have that pointer? Yeah. That's our first president. I think he ruled for, did he not rule for 39 years? I don't know, I've forgotten. For a very long time. At some point, things started to go wrong. And the money becomes worthless. You get $1,000. Tomorrow it's worth 1 penny or something like that. So there was a capital flight, there was human flight from Zimbabwe. Luckily for me, I had gotten a scholarship. I had been planning I need to have a PhD. I need to have a PhD, and that came through. So I was on the plane coming in. I think it was still the Air Zimbabwe plane. Sat next to a student. They said, Mr. Nyamapfene, where are you going? I said, to the UK. I'm going to do a PhD. Of course, you talk importantly because you are a lecturer. And he said, me, I've quit engineering. I'm just going to take any job. I want to survive. That was the issue. For me, I was quite okay. I'm going to do a PhD, but I didn't know where I was going. Thankfully, there was support in place. Pastor Sam and company, they were there. My brother were there. I managed to get through. Then I was given charge of the MSc Power Systems program. That was the University of Bath. And for some, along the way, he had managed to get into National Grid. He was now doing the MSc Power Systems. And the most important thing was there was an entrepreneurship module. It was run by the School of Management, but one thing is, for that entrepreneurship module, students had to focus on an area that was particular to what they were studying. So, of course, he opted to focus on what? Renewable energy. So it was an entrepreneurship module, almost project-led. He's doing a project again in renewable energies. He combined them together. What happened? 2024, I'm here talking proudly about the IEP, isn't it? And he has become one of Southern Africa's preeminent renewable energy entrepreneurs. So from a place of hopelessness, coming here and onto this MSc program, I did not design that entrepreneurship module, but what I realized was entrepreneurship, no matter how you look at it, when properly coupled with education, it can change individuals' lives and it can change nations. He's based in South Africa, he's expanding into Zimbabwe, he has expanded into Namibia. If I look at my bank account and his bank account, I shall not comment further on that. But that's the power of transformative education. Okay, those are the lessons. I think I am now concluding. This is some of the work I have done with students, looking at entrepreneurship in the community. That was in 2013 before I came to UCL. I've talked about how to change the world, how literally it is transforming lives. Pictures there, students actually talking eloquently with people from industry, others being promised jobs, opportunities, internships on the spot. And I would have wanted to talk about the good work that is happening in Georgia. It's one of the former Soviet countries. And some of them have this idea that we can actually teach entrepreneurship to all our youth. And I was thankfully invited to participate in this project. You sit there, you talk with people, and you see they are so hungry for change. They believe in what they are doing. And looking back at my work at Bath, I realize they've taken it 10, 30 times up. They are spreading it across all universities in Georgia. And it will be project-led. I think I did put in my 2 pens there, but most of the stuff they'd thought through. And the key thing was those students are not going to write an exam, a test on entrepreneurship. No, they are working on projects. They will have people who are actually entrepreneurs. I set up a pizza shop. I set up a shop to do this, an electronics shop. They talk to them, what did you do? How did you manage this stage? We are at this stage of our project. How did you do this? They talk about it. They advise students. They look at their work. This is the dream that they have. And I'm sure if it takes off, you can see a whole country turning around. And I'm excited about this. I could go on. What have I learned about teaching? We know very little about teaching unless you are in it. But still, that applies to every professional field. And most importantly, teaching can be complex or very, very complicated. So I often look at my, I wanted to mention names, but okay, my wife then. You talk about teaching, oh, that teacher is not good, oh, they are not doing well at school. But it's extremely complicated. No, I just picked you. Having happy, successful students. And I'm so grateful to all these people here. each and every one of them has made a huge, huge change in my academic career, and I'm so grateful. Thank you.
Hi there. So, Abel, you've got away with it because you've overrun, and now I can't tell stories. I'm not going to keep you long. I am going to put the stories on one side, but I want to go back very, very quickly to one of your slides, in which you have made 3 points about education. And Abel showed me his slides yesterday, and I said, the one slide that really makes me think of you is this. And this morning I was thinking about that, and I was thinking, why does that make me think so much of Abel? You've seen tonight Abel's joyful spirit, you've seen his generosity, you've seen his intellect, you've seen the depth of what he does, you've seen how he treats his colleagues. He's a wonderful, wonderful colleague. And this is what I think of Abel. He's authentic. He always puts the other person at the centre. Whenever you're with Abel, he puts you at the centre. And he's the only person I've ever seen give an inaugural lecture who started by saying, oh, welcome, welcome, I'm so glad you're here, and I'm so glad you're here, and here. And Abel's spirit is in itself transformative because he has such trust in the other. Ladies and gentlemen, I give you Professor Abel.